Okay, in this video we are going to be talking more about vocabulary and how to do a couple things with segments. So if you want to pause this video right now and do the warm-up, go ahead and then press play and I'll have the answers up. Okay, so first here we have a point. Next we have a line. Then we have a plane. How am I figuring all this out? I'm just looking at that notation. So the next one is just a bar with no arrows or anything, so that's a segment. And then next we have one side that has nothing, and then the other that has an arrow, that's a ray. And lastly, that is just going to be talking about the distance. And we're going to talk about this guy here today. Okay, so first we're going to talk about betweenness, and I just realized I have a couple things drawn on here. Okay, so betweenness is going to be when you have point B is between points A and C if and only if A, B, and C are collinear. So collinear, remember, is when they all lie in the same line. Then we're going to have here, we can say that AB plus BC equals AC. Okay, so what does that look like? We're going to do an example. Okay, so in this example, we're going to do the first one. It'll make a little bit more sense on what betweenness is. We have here, how long is AC? Well, AC is the entire line. So I'm going to take each individual section, add them, and it'll equal the full line, AC. So we have here 1 centimeter for AB plus BC is 2 centimeters equals. So AC will equal 1 plus 2 is 3. When we write our answers, AC equals 3 centimeters. Notice why I didn't put the bar on top. The next example, this one is asking how long is AB. AB is this short distance here. It is not that full one. We're still going to do the same exact thing. Up here, I have this written down. I highly suggest that you do the same thing as you're doing your notes and your homework and moving forward. So AB, we don't know what it is. So AB equals BC, we know, not equals. AB plus 6 centimeters equals AC is 11. When you go ahead and solve, you'll get AB to equal 5 centimeters. Remember to put that notation, the units there. Next, we have midpoint. So midpoint, exactly what it sounds like. You have a line, midpoint, it's the middle of the line, or I'm sorry, the segment. So here, B is the midpoint of segment AC if and only if it is between A and C. So then we can say that those two mini segments will be equal. So here's an example of this line. So we have the segment, this line segment AB. This line segment AB has the point M in the middle and these two tick marks. Those two tick marks show that something is congruent. So that's talking about the picture. So congruent talks about the picture. Okay, so equal talks about the size. So congruent, you'll see is the notation as that's an equal sign with a squiggle. Equal is just an equal sign. So over here, AM equals BM, so we know M is the midpoint. Next, taking a look here, we have an example. So this example, it says 3 segments. Measures are given. The 3 points named after them are collinear. Determine which point is between the other 2. Okay, so all we have to do is look to see which point is between the other 2. This one here, NQ is 17, NK is 6, QK is 11. Clearly, NQ is the longest length, and so I'm going to go ahead and draw a quick picture to test this. So we have NQ. Notice my points for each one, and then I'm going to put in the middle the K. So here NQ says it's 17, then NK is 6, and QK is 11. Does 6 plus 11 equal 17? Yes, sure does. So then we know that it is K who is in the middle. So K is between. Alrighty, the next example is E is between G and H. What is the value of Y and the length of GH, segment GH? So same exact process as before. We have a segment. We have here GE plus EH equals GH. I'm going to go ahead and plug in what I know. So we know GE is 3Y. We know EH is 24. And set that equal to 7y minus 4. From here, I'm going to go ahead and solve. So I'm going to end up having a 28 equals 4y. Then we go ahead and divide. We will get y to equal 7. So y equals 7, but now the question is not over because it wanted the value of y and the length of segment GH. When we go ahead and find the segment GH, finding that length, GH equals 7y minus 4, plug in 7. So then we will have here 7 times 7 is 49 minus 4. We will get 45 is GH. Alrighty, the next example is drawing. So this is a really tricky one that some people have issues with, especially in the beginning. I promise this is something you'll get better at as time goes on. Make sure you're doing everything exactly as I do it. So points M, A, N, and Q are collinear. Points N is between points A and Q, and point M is not between points A and Q. So first of all, it's talking about something collinear, so I'm going to draw a line. Notice I have arrows on there. We have these 4 points. Point N is between A and Q. So I'm just going to draw in 2 points, A and Q. And when you're doing this, you can always erase and move things over. And it says N is between. Okay, and then it says point M is not between A and Q. Okay, so you can put M on the left or the right side. I'm just going to put it on the right. We have point M. And that is it. That is all it asked. The next question, there's more than just drawing it. We also have to add some notation of things being congruent. So we have here another line. G is the midpoint of KJ, and KJ is equal to JY. So we have a line. Okay, we have 4 points. I'm going to first start out with actually this last statement here, KJ equals YJ. So I'm going to put the K and then over here the Y, and you'll see why I did that, and then J in the middle. Here, J is happening in both of them. Okay, we know that they're both equal, so these segments are going to be congruent. Awesome. And then it says that G is the midpoint of KJ. So KJ, we have here a point, and I'm going to put an M. That's actually not an M, I'm thinking midpoint, that is a G. But then I also know that it's the midpoint. So over here, this segment, KG, is also congruent to KJ. So notice how it looks a little confusing with all the notation, not just the letters and the arrows, but the tick marks. You have to add the tick marks. They have to be noticeable. The next example, I'm going to skip that. And then we have here some properties of equality that we will be using on a daily basis. So the first one is reflexive. That is when something is equal to itself. So AB equals AB. That's like if I said 4 equals 4. Well, yeah, of course, duh. Symmetric is when you have something like AB equals BA. Or you can have A plus B equals B plus A. You're just switching the order. Transitive is a little trickier, but this example is A equals B. And then we also know B equals C. So then I can say that A equals C. Notice here, B and B, they're both equal to A and C. So then if I have these two are equal, I can then make another equal statement over here. Next is substitution. So this is if we had an equation, let's say AB plus BC equals AC. And I know that BC equals KH. Oh, okay, well, that means I can take this KH and plug it into here. So then we'll have AB plus KH equals AC. And that's a true statement. All right, the next is a couple examples of filling them in. So if you'd like to pause and try doing them on your own and checking if they're right, that's a great way to practice. So the first one here, GH and HG, those switched, so that's symmetric. The next one, we have this statement, and then we also know that CD equals HJ, this CD here. I can plug in that HJ into here, so that is substitution. I'm just abbreviating it. I'm not writing the full word out. The next example is RJ equals PK, RJ equals MN. I already see a trend here. RJ happens twice. So then PK equals MN. So I can say these two here are equal, and I can write that there. So that's transitive. The last one, or not the last one, this one is reflexive. They're equal to each other. Duh, right? Okay, so then the next one here is another example of substitution that you can see. So BK is equal to 4. You can take that 4, plug it into BK, and that's the only thing that changed. So that's another substitution. Next, here we have congruent statements. So a congruent, not congruent statement, a congruent segment is two segments, and I'm going to abbreviate, with the same length. Okay, you can also see it as two segments with the same tick mark. All right, and so again, congruent statement, I mentioned it before. So something congruent has this lovely squiggle here. Now I'm going to go ahead and write all of the same things that we did up here. So I'm going to write the same properties, but with a congruent symbol. Okay, so the first one here, and this is what we would use for proofs. Congruent segments are reflexive. So here we will have AB is congruent to AB. Notice when I'm doing congruent, I'm going to add that bar on top versus when they were equal, you do not have the bar. The next one is congruence of segments is symmetric. So segment AB is equal to congruent to segment BA. So it's switching that over. The next one is congruent segments of a transitive. This one here is going to be segment AB is equal to segment BC. And then we have here segment BC is congruent, and I forgot my squiggle, to segment PR. So then we can say that segment, well, it looks like here BC, BC, so we can say segment AB is congruent to segment PR, and that would be the transitive property. And then a segment bisector. So a segment bisector is when you're going to have a segment. Okay, so let's say segment AB, and it is going to be bisected by a line, or it could be another bisector, but I'm going to put a line here, line L. When something is bisected, you will be getting the midpoint. So when it's bisected, it cuts it in half, so I'm going to put an M, so then we can say that AM, so segment AM is congruent to segment MB. So the definition, I'm going to go ahead and write that down. All right, magic. Here's the definition. So a segment is a segment bisector if and only if it passes through the midpoint. And so we're going to have a lot of practice with that. Alrighty, that is it with these notes. If you have any questions, just let me know.